Here's a quick, fairly general example of completing the square in a quadratic expression. I do like to emphasize that this is all about manipulating an expression, not necessarily an equation. This can happen within an equation, but it does not have to be within an equation. So we're just taking this, which you could think of as a function of x. It has a graph, it's a parabola, that kind of thing. And we're going to write it in a way that it makes it much easier to do certain important things, like find the vertex of that parabola, things like that. So this is not assuming, this is assuming you've seen completing the square, at least the idea. And I just want to lead you through an example where it's a little tricky, mainly because of this coefficient. So the way I would do this is whenever this coefficient is not equal to 1, is I would factor that out. You could factor it out of the whole thing, but it's really just crucial to factor it out of the stuff with x. I like to emphasize that the constant here is really kind of just going to come along for the ride. It's not bothering anyone. It's the variables that make expressions complicated. And so I just factor it out of the parts with x. And then I do the completing the square entirely within these parentheses, just on that sub-expression. And there the key is that you're going to divide the 10 by 2. And we're going to think about what x minus 5 quantity squared would be if we expanded that out. Let me just remind you how that works. We're really undoing the perfect square trinomial formula. Aha, that would have a 25 in it. This does not have a 25 in it, and so we're just going to subtract it off. So we are correctly matching the x squared. We're correctly matching the minus 10. We accidentally put in a 25, but it's super easy to fix that. We just subtract it back off. Now, the minus 38 is still along for the ride. And then the only thing I have to do is put the constants together. This actually isn't a horribly complicated form, but it's got the constants, two constants in different places. So we just distribute the minus 6 back. Notice that turns that into a plus 150. Okay, and we've accomplished one of the most important things in any kind of algebra, which is taking something that had two instances of the variable and replacing it with just one. If you're going to set this equal to a 0 and solve, if you're going to find the vertex of this parabola, a lot of other things, this is a better form. The mistake people usually make here is not factoring out the minus 6 correctly, and in particular, just not factoring out the negative correctly, especially when this is a negative factor. I think it's more likely to happen and give a problem where this is positive and this is negative. I see it more often because I think your brain is not expecting this to turn to a negative, but it does. When you factor a negative out of a positive, it turns negative. And notice at the final, in the final answer, it was x minus 5 quantity squared. We wouldn't have gotten that correct minus without dealing with the interaction of those two signs correctly.